Hey everyone, welcome to The Explainer. Today, we're going to tackle a word you probably hear every single day, but maybe you haven't really stopped to think about what it truly means. That word is model. Now, it sounds simple, right? But underneath, it's an incredibly powerful idea. All right, let's dive in.
So, let's kick things off with a little bit of a puzzle. What do you think connects a fashion model strutting down a runway, the weather forecast on your phone, and something like ChatGPT? I mean, they seem totally unrelated, don't they? But they all share this one fundamental identity. Yep, you guessed it. They're all models.
And this is the key that unlocks the whole thing. The core definition we're working with is that a model is just an informative representation of something else. It could be an object, a person, a whole system. That's it. That one simple idea is the thread that ties all of those different examples together.
But, of course, there's way more to it than just that. So let's unpack that definition a little bit and really explore the amazing world of models.
You know, it kind of helps to look back at the word's history. Model actually comes from the Latin word modulus, which means a measure. And when it first popped up in English, way back in the late 16th century, it was used for building plans. You know, a representation of a building before you actually build it. It's like the perfect original example of our definition. Okay, to really get a grip on what makes something a model, there's this really powerful framework from a philosopher named Herbert Stackawayak. He basically argued that every single model out there, I don't care what it is, has three essential properties. You can think of it as the blueprint for what a model is.
All right, here they are. First, there's mapping. This just means a model has to represent something else, its original. Second, we have reduction. Now this one is huge. A model is always simpler than the real thing. It has to leave stuff out on purpose. And third, there's pragmatism. A model is always built for a specific reason, for a specific person, to be used in a specific way.
Let's use a super simple example to see how this all fits together. Think about a street map. It's a model of a city. That's the mapping. It leaves out all kinds of details, right? Like every single tree, every traffic sign, every pothole. That's the reduction. And its purpose, its pragmatism, well, it's to help you get from A to B without getting lost. Simple as that. Okay, so now that we've got that blueprint, we can start putting models into different buckets. And broadly speaking, pretty much every model you can think of falls into one of two big families: physical models and conceptual models.
The difference is actually pretty straightforward. Physical models are, well, physical. They're tangible things you can actually touch. They could be smaller than the real thing, like a model car, or sometimes even bigger. Conceptual models, on the other hand, are abstract. They're built out of ideas, out of language, out of math.
So let's look at some physical models. I mean, you've got your classic architectural models for buildings, right? But things can get way more creative. Get this. Before computers were a big thing, economists in the UK actually built a water-powered machine called the Moniac to model the entire national economy. And think about this. When scientists study a guinea pig to understand human diseases, that guinea pig is actually serving as a physical model for our own biology.
Okay, now for the conceptual models. These are those blueprints made of pure ideas. The crazy complex math that runs our weather forecasts, that's a perfect example. Same goes for the economic theories that try to represent how markets work. And yep, you guessed it, ChatGPT is a conceptual model, a giant language model to be specific. Heck, even the picture you have in your own head about how the world works, that's a conceptual model too. Psychologists call it a mental model.
Okay, so we've covered what models are and the different types. But that really brings us to the most important question of all. Why do we even bother? What is the point of making these simplified versions of reality in the first place? What's the so what here?
I mean, think about it for a second. If every model, by its very definition, has to leave stuff out, if it's always a simplification of reality, then what are they actually good for? Why would we ever rely on something that we know is incomplete from the start?
Well, it turns out that simplification is actually their superpower. According to researcher Bruce Edmonds, that's the whole point. He came up with 5 key things we use models for. They help us predict, explain, develop theories, describe things, and illustrate ideas. Let's zoom in on the 2 biggest ones. First up, prediction. This is probably the one you think of first. We build a model of a system, say all those math equations that describe the atmosphere, and we hit fast forward to see what's likely to happen. This is how we get weather forecasts, financial projections, you name it. It's all about trying to get a reliable sneak peek at the future. But just as important, if not more so, is explanation. This isn't about looking forward into the future. It's about looking deeper into the present. A good model can help us figure out why something is happening.
By simplifying reality, we can kind of pull things apart, isolate the important pieces, and figure out cause and effect. And that's the absolute core of science.
And all of this brings us to our final and maybe most crucial point. There's a famous saying in science and philosophy that goes, "The map is not the territory." And when it comes to models, that is the most important thing you can ever remember.
This really gets at a critical difference. A model is not reality. It's just a representation of it. As this great quote points out, a model just tries to represent reality for a particular reason. A theory, on the other hand, is much more ambitious. It claims to actually be an explanation of reality. So you see, models are the tools. They're the maps we use to explore our theories. They are incredibly useful, but we can't ever mistake the map for the actual place.
So, that leaves us with one final thought to chew on. Remember how we started. Every model works because of reduction, because it leaves things out. Well, as our models get more and more powerful, think about climate simulations, think about AI, they become almost unbelievably complex, but the fundamental rule still applies. So the question we always have to be asking ourselves is this: what are we choosing to leave out? And, maybe more importantly, what are the consequences of those choices?